Welcome to Excel Tips. My name is Neale Blackwood, and in this video we're going to be looking at how we can build this dashboard using Excel's new dynamic array formulas. You need the subscription version of Excel to use the techniques covered in this video. So this is the third in the series. So in the first video we did a revised 12-month report. In the second video we did this month and year-to-date report, and we will today look at how we can build this dashboard. We're using the same data sets as we have used over the other two, and we're just expanding on some of the techniques that you can use with dynamic arrays to make your dashboard dynamic. So as we add more actuals to the data set, the charts on this dashboard will automatically update. Now this is an interactive dashboard, so we've got the asterisk there, so that represents all of the states. So we've got 3 states listed, so you can select a state and have the report update, or if you choose the asterisk, that means all of the states. So I'll explain that when we get to the formulas. You can also choose the comparison, so it can be either the budget or the prior year. So updating that only updates these 3 charts. It doesn't affect the other 6 charts. So what we're covering today is revenue, profit, and profit percentage. And that's what we're mapping on each of these 3 sets of charts. So the first set of charts covers the current financial year, so from July through to January at this stage. The middle set of charts is a rolling 13 months. So 13 months encompasses the same period last year up to this period. And then we've got the ability on the last set of charts to select a number of months for each of the measures. So at the moment it's sitting on 6, but we can change that to 9, and so the charts will automatically update based on that number. Okay, so let's go look at the structures we're using. The control sheet is used to calculate sort of the months that we're going to be using, how many months we can have. So at the moment there's 19 months of actuals data, so that's the most we can have when we're plotting, for example, but it also means we've got access to the previous year's data. So the GL data, this is the same data structures that we have been using in the previous 2 videos. The main thing to pick up here is that the revenue is shown as a credit, so we do need to reverse the sign for our reports. The budget data, again, a typical budget structure, which has its own issues, which we'll see how we can solve in the formulas. So it's got all of the accounts going down the page and the months of the year going across the page. The GL data has the dates going down the page. This is a lot easier to work with. This is a typical data structure. We've got some tables, so these are all the accounts that we have. We've got a description, we've got the category and the sign. The sign is used to reverse the revenue, so we'll see how that works later in the video. We've also got range names. Range names can shorten your formulas, and I'll explain that as we get there. So these are some of the range names that are used within the file. So we're referring to this table, which is the table accounts. There's also the GL table, which has the ACT for actuals, and then we've got the budget sheet that we're using BUD as the prefix for. So we'll come back to that. Okay, so I'll just go over the charts quickly. So the first set of charts is a variance chart. Now all of the instructions to build the chart are in the article, so you can check that out on the In the Black website. This file you can download from the In the Black website as well, so check that out. This is a variance chart, so it's plotting the variance on a month-to-month basis. So what this chart is showing us is that we were pretty much on budget for the first 4 months, and then something happened in November, December and January, and we are under budget for revenue. Each of the columns represents the monthly variance. And then the orange line is the year-to-date result. So you can see the monthly variance as well as the total year-to-date variance in one chart, which is really useful. And so that's the same for each of these. If we change the comparison to prior year, for example, you can see we're actually going better than prior year, though apart from January where we dropped a bit. And so again, you can see the year-to-date comparison in the orange line. And so that's the same for both the percentage and also the profit. You can see the profit and the percentage have been worse all the way through. So even though revenue was on target, our profit and our profit percentage have been below budget. Rolling 13 months. Now, this one is not dynamic in the fact that it's always plotting 13 months worth of data. So this data automatically expands. This data we've already seen can expand when you change the number of months that you want to plot. The middle charts don't need that because they're just doing the rolling 13 months. So the number of data points don't change on these, on the middle charts, but the left and the right charts do update based on the criteria that we've set. Now we've just got some basic line charts here. So we're plotting on the blue line, it's the raw revenue result. Then we've got the orange is a 3-month moving average, and then the grey is a 12-month moving average. Using moving averages is quite useful because that gives you the ability to smooth out some of the ups and downs that you get month to month. And then the last chart, so this is just a basic column chart, but it does have a trend line in there. So you can see revenue is trending up slightly, profit in the last 6 months is trending up, and profit percentage is trending up. But if you switch it to 9 months, you'll see that it's a little bit flatter, especially the profit, and you can see that the profit percentage is actually falling there. They're the charts that we're creating. We'll come back to the dashboard and I'll show you how you can line up the charts and resize the charts a little bit as well. Let's go now and look at sort of the data that's making all of this happen. Now, I'm a big proponent of having working sheets. So working sheets make things a little bit more transparent. It's easier to track back where the values are coming from. There are a few formulas in this sheet, but not a lot because they're using dynamic arrays. So they're spilling across and they're spilling down. I have got, if you follow this link here, a listing on the side that does go through and list the formulas. And you can see there's a couple of longer ones which we will go through, and whether they spill and the direction that they spill. This is a summary of the formulas in this sheet. There's also a summary in the chart data sheet when we get there. So this sheet creates all of the figures we need to create the charts. Now, it's the summary that we'll be using that's up the top section, and that's based on the detail which is underneath. So there's actuals, and there's budget. Okay, so they have the same structure. So the budget has a summary and then the budget has the detail. They work pretty much the same. There's one formula that's different that I'll go through. So this is driving the sequence of months. So in the actuals, there's 19 months. So that control sheet B11 has 19 in it. And so it's creating 19 sequential numbers going across here. This is creating all of the months that we need to identify for our actuals. To get the range to spill, we start with our, again, the control sheet has the starting month, and then we are using the spill range in row 4 to increment the dates. To refer to a spill range, you use the top left cell followed by the hash symbol. So obviously we don't want to increment the July, so that's why we're subtracting 1 from it. The eDate function increments a date by a number of months. And so that works for all of the other dates. So we get all of the dates populated. I'm going to come back to these 3 formulas. They are summarizing the revenue, direct costs, and then indirect costs from basically the detail underneath. So I'm going to come back to those. The profit, very straightforward. We're just taking the revenue, deducting the direct costs, and deducting the indirect costs to get the profit. And again, you just use the hash symbol to refer to the spill range. The profit percentage is just dividing the profit by the revenue. Okay, so this one here is bringing in the dates again, so we can just refer to that date listing from row 5, and that's spilling across. On the left-hand side, What I'm working with here is that accounts table that I showed you earlier. So this brings in the headers from the table. Underneath, it's bringing in the data. And so you can see the formulas that extract out of the formatted table are very short. So TBL accounts brings in all of the detail from that table. And then TBL accounts headers brings in the headers there. So based on that range on the left-hand side, we're going to summarize the actuals data. Here we go. We're doing a SUMIFS. So SUMIFS is a conditional summing, where this says we're adding up the actuals amount column, which is in the GL datasheet, and this is the range name that refers to it. I'll just show you those range names again. The reason I use range name, so that's the range name that I'm using, ACT amount. If I wanted to use what's called the structured reference, it's a lot longer. So it has the table name in front of it, followed by the amount in square brackets. So when you build a formula using structured references, the formula does get very long. And I find the longer the formula, the harder it is to read. And that's why I prefer to use range names that refer to these structured references. So as you can see, the structured references can get quite long, but the range names in this case are quite short. What I do is I use a prefix in this case. So ACT is for actuals, BUD is for budget, and ACC is just the accounts table. We're summing up the amount column in the actuals when the account column equals this index. Now, index is a really easy function to refer to a two-dimensional spill range. So A13 is that listing of all of our account numbers. Now, it's spilling across and down. To refer to the first column, all you do is you refer to the two-dimensional range. You have a comma and then another comma. So what that means is, so you want to return the whole column from that spill range, and it's referring to the first column. So this formula, which is fairly short, is returning the first column from that spill range in A13. So it's going to refer to all of the rows there. So it's going to spill down because of that. Now, we're also going to look in the date column in our actuals and refer to, in this case, July 22, which is in F12. Having the hash symbol there is going to spill across. So the index is going to spill down and the date is going to spill across. And then also we want to look up the state. And that's in B2, that's what we've chosen. Now, at the moment, it's the asterisk. The asterisk is a wild card in Excel. So what that represents is every single state, basically. So that's returning the company's result. If you chose a state, then it would filter by the state's value. And lastly, we're going to multiply by this sign column, which is the fourth column in our spill range in A13. And then that converts all the negative revenues into a positive revenue. So that one formula is summarizing the whole of the actuals table. Having got that, let's see how we summarize the detail. So that's giving us the detail. Now we can summarize it. Now this formula is reasonably complex. So I'm going to sort of show you how it works by breaking it down a little bit. We've got a filter in place. So what this filter does is it takes that spill range that I just showed you. So that's the summarized actuals, but by account number. And then I'm filtering it. Again, I'm using this index. I'm filtering it by that table on the left-hand side when that in the third column equals revenue. So that's the category. So I can filter the right-hand side spill range by the left-hand side spill range. And I'm filtering it by the third column, which is the category column. I'm going to take that part of the formula out. I'm going to copy that. And I'm just going to scroll over here. I'm going to Control V that and put an equals in front of it. So this is what the filter function is generating. It's summarizing all of the that percentage is wrong. It's not a percentage just because I've got a percentage on that row. I'll just get rid of that percentage. There we go. So that is the revenue from the section below. So we've got 2209 down to that 2807. So if we go back here, There's the 2209 down to the 2807. So that's summarizing, it's filtering this list by that list, and it's only giving us the top 5 rows here, which are the revenue rows. Okay, so let's go back over there. And so that is what I'm going to use the by col on. So by col splits up a range, and you have to use the lambda function to get the variable. And once you've got that variable, you can do a calculation with it. So what the by col does is it splits up a spill range by column, so by col. That column is given to the lambda in the x variable, and then the sum just adds that up. So what I've done in 2 formulas here, so I've done the filter and I've done the by col. What I've done in 2 formulas, I've done in 1 formula back over here. The filter is providing a spill range, and then the by col is chopping that up into columns, giving it to the lambda. It goes into the x variable, and then the sum. The x variable is whatever you want. You can have any variable name you want. When I'm using something like this, I just use x as the variable, and that sums it up. The beauty with that is it spills across. So that's why you need the by col function to basically add up a spill range that's 2-dimensional. And each of these is exactly the same formula, but it's doing direct costs, and this one's doing indirect costs. So that structure is the same for the budget. So if we scroll down to the budget, that is the same formula, but it's using the budget entries below. This one has a SUMIFS function as well, but it's got one extra complication. So in our actuals, the column we wanted to add up, the amount column, is just a single column. It's nice and easy to add up. In our budget, the budget goes across the page. So the column we want to add up is actually moving. It's literally a moving target. This offset function here will create a range that moves across the sheet. So we're moving this budget account column, which is the account column, I think it's column C, and we're not moving in any rows, but we are moving at a certain number of columns. So, and that's generated by this 1 to 12 in row 65. And so that's the amount, that's the column that we're going to add up. I'll show you the budget sheet. This is our account range. If I highlight that, it should tell me, there we are, BUD account. So that's the account range. And then we're offsetting that. So we're taking that as a starting position and we're offsetting it 1, 2, 3, 4, all the way over to 12. So that's the complication for the budget, because it's not really a data structure, it's like a report structure. And so the offset gives you that ability to move across the page. And then we're just doing, we're adding up the account when the account equals 3100 and when the state equals B2. So same sort of deal. The complication there was the column to add up. Okay, so that is the working. So that gives us all of the raw materials we need to then build our chart data sheet. Now this is broken up into 3 separate sections. So we've got our variances on the left. We've got our 13-month rolling in the middle. And then on the right-hand side, we've got the one that varies based on the number of months that we key in. So they're pretty much the same. I'm just going to explain the sort of the top section, which is the revenue section of each one. This one is dynamic. So as months are added, they're added to the table that we're going to build here. Okay, so let's see how this works. So we've got, again, a sequence that's driving the number of months. So at the moment, it's 7. Another function here that's going to eDate increments dates, and so that's creating our dates for the table. So to get the correct data from the working sheet, we need to identify the column that has, in this case, July's value. So we can use the match function, which returns a number, and that looks in row 5 in the workings, and it tells you what position July 23 is in. So it's the 13th column. And you can see that gives us all the numbers across to 19, which is the last column at the moment in there. It's a bit simpler for the budget because the budget only has 12 months. And also the prior year is starting in the July 22, so it's actually column 1. But we can use that same match function structure to identify the columns. Now, having identified those columns, we can use those column numbers in all the sections that are below. Once we've got that, it's really easy to extract out the actuals. So in this case, what we're doing is we're using the index function again. I use the index function a lot. There is a single row spill range, and when you just refer to one entry in it, it's actually going to bring out the column. Even though this says it's the row number, it's actually going to extract out the column because this is a single row spill range. And so this is going to get the 13th column in that row. So let's go have a look. So we're in actuals, revenue, let's have a look. So what we're looking for is 4.69 million. So we've got actuals and we want July. There it is, 4.69 or 4.689. I have used, I'll show you this, the format here. This is shown in the article. I'll just show you what the format is. That's it there. Using the commas on the end here, 1 comma would round to 1,000 and 2 commas rounds to 1,000,000. And then you can just put the M on the end to stand for the million. So that's called a custom number format, and that's been applied across the board here. Okay, so that's extracting the 13th column from that range. So the budget working the same idea, but it's working with different numbers. The budget is on that row, and we're extracting, in this case, the first column. Prior year's the same. We've got one row we're extracting from, and we're extracting the first column. So that's our raw materials. Based on what's selected, whether it's the budget or the prior year as our comparison, I've got a very simple formula to bring that in here. We can build up our text string title. The ampersand symbol here is joining the text together. So we get the text revenue dollars, variance to budget. And then we just do a very simple calculation here of deducting one from the other. And then the year-to-date one. This one is a new function called scan. I have covered it in a previous article, but what it does, it allows you to do a running total, basically. So the first part is the opening balance, or the initial value, which is 0 in this case. And then we're taking this range, which has got 0.02 million in it at the moment, and we can use the lambda function. Again, you have to use the lambda function. There's 2 variables required, x and y, and we add them together. The lambda function is going to transfer this total back to the x for the second column. So the first column takes 0 as x. The second column is going to be whatever we added up in the previous column, and that goes to x. And then it just works its way across, and you get a running total, which does get worse towards the end of our the financial year there. That's the values we need. The way to make this dynamic is to create a single range that you can then refer to when you're building the chart. And to do that, we can use 2, again, new functions. There's HSTACK, which stands for horizontal stack, and VSTACK. Now let's see what VSTACK is going to do first. What VSTACK is doing, it's combining the headings for the dates in row 3 with this section here, which is 14 and 15, which is the values. So what I'm going to do is I'll show you what that looks like by itself. So I'm going to copy that. I'll go off on the right hand side here. So that's actually the VSTACK that is there. And as you can see, actually their dates, so if I convert them to dates, you'll see the date. They're dates, and then these are values. But for our chart, we need our headings. The VSTACK joins the ranges one above the other. It's like an append if you've worked with data. It's appending one table to another, and that's vertical. Now we need our headings, and that's where the HSTACK comes in, because if we go back and have a look what the HSTACK is doing, this combines that range there. So revenue, month variance, year-to-date variance. So the combination of the HSTACK, which basically puts a column to the left of the VSTACK and creates this two-dimensional range. And that is what was used for the chart. And so the chart is going to expand when we add February's data to our data set. That was the current year variances. All of the ones below it are all pretty much the same, but just doing a different measure, whether it's profit or profit percentage. The 13-month rolling is a little bit different in that it is a fixed width or a fixed number of columns, so we don't need this to expand. We do need it to update, but the actual range that you're using for the chart doesn't change. This one's not as complex to create. Again, we've got our sequence. This one's again finding the date based on the sequence there. So we're using the 7th column as the first one, which is going from January 23. And again, we're using eDate to increment the dates. And we're using that same index function to extract the revenue. This one's a little bit more interesting. This is how we calculate the 3-month moving average. So this is using an average if S function to do that. Sum if S, sums, well, average if S, averages. And so we're working with the spill range in F6 in the workings, and basically we're looking in the date for we're greater than, say, the -2. So again, when you're working with dates, the eDate, that's 2 months before. In this case, that's going to be November. So greater than or equal to November, and then less than or equal to January. And so that gives us our 3 months. And so as this goes across, it averages out the previous 3 months. And then we do exactly the same one here, but we use -11. We use one less than the number because it's inclusive. So -11 is giving us the 12-month moving average. And they all spill across. And again, because it's a fixed width chart, we don't need to worry about creating a single spill range for the rows and the columns. Okay, so that's that one. And this one does need that single spill range. So what we do pretty much here, we're trying to figure out the last 6 months. And so we're using, again, a spill range here generated by sequence. So that's basically saying we want to start at 19 and work backwards, if you like. So we've calculated how many months we need to deduct. So that's in this case 5 months. Again, remember it's an inclusive month. So we're going to start at the 14th column in actuals and go all the way to the 19th. Again, we can increment the dates and then bring in, using that index function, to extract out from the range. And then this is our HSTACK VSTACK combination again. So VSTACK is joining the two rows together, and then HSTACK is putting the labels on the left-hand side. So that's all of the workings for the charts. And again, each of the other charts below uses that same sort of structure. Let's see how it updates. So I'm going to go to my GL data, and at the bottom, I have prepared earlier the February figures. So let's go and copy this and drop it in here. So I'm just going to paste that. You'll notice that the formatted table has extended down automatically, and because of that, our dashboard has updated to February. Okay, so we've got February, 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 and now everything's good. And again, if you want to choose a state, you can, and it will all update. One of the problems when you're putting charts on a dashboard, you do need to line things up. So a couple of things. Let's just mess this up a bit. So let's make this a bit wider and a bit wider, and let's sort of move this over and make it a bit wider. So one thing you need to do is line them up. So to do that, just hold your control key down and select the charts, and then you'll have a shape format ribbon open at the top, and one of the options is align, and you can align left. Okay, so that's the easy bit. So you've aligned them up. Now you need to make sure they're the same width. So what you can do is, I think I'm just going to drag one in. Okay, and that's dragged them all. Now they're not quite there yet. So what I'm going to do is just have a look at this one, because this one's pretty right. If I have a look at the format, it tells me it's 9.35 centimeters wide. So what I'm going to do is make these others the same. So again, hold my control key, shape format, and was it 9.35 centimeters? And so that's made them the same. Now you might want to make them the same height as well. So this one was 5.96. So I can go here and make them 5.96, and that will get them the same height as well. This one here probably needs to move up a bit because I've already put the dark lines on there. So there's some tips in terms of lining your charts up, getting the charts the same height, the same width. Okay, we've covered a lot of different techniques here. Hopefully some of them you'll be able to use to make your dashboards more dynamic and interactive. Now you might need to watch the video a couple of times to grasp some of the concepts as they are new. Just remember you can download the example file and check out the article on the In the Black website. Hope you've enjoyed the video. Thanks for watching.